All right. Hey, my name is Jeff Hilland. I'm DT at HPE Labs. Also serve as DMTF president for the last 11 years, I think. SPDM co-chair, hardware management project, and OCP co-chair. Been doing this for a little while. So what I'm presenting on today is Redfish for storage management. Largely, this is the changes that are in Redfish that have been put in specifically for storage management, most of them for SNIA, some of which Rochelle talked about earlier. Some of which she didn't, though. Then I think there are changes that are generally applicable to some of the storage environments. Got a little bit of background on DMTF, who we are and what we do, and you know, wouldn't be doing my job as president if I didn't do a little bit of that. We've got a really supportive board. You know, I appreciate everybody who's on here. It takes a lot of effort to put people in an organization that are in charge of the care and feeding of that organization and really care about the mission to see what we do and take it to the industry. We've got a bunch of leadership companies as well that help us a lot. Takes one of those to chair one of the organizations, and it's I don't know, it's really nice to see the support we get from the industry, both the alliance partners as well as our board. We've got a bunch of different chunks of alliance partners. It's a nice way of chunking them up here, whether they're Redfish or Cloud or SPDM or MCTP. There's a few that aren't on here that reference our standards. These are just the people that we tend to work with. But Rochelle said it, I think, best. I mean, there's nobody we've got a working relationship like we have with SNIA. The fact that we're meeting every other week, joint meetings. In fact, I saw the disclaimer slide on my desktop. We do this disclaimer. It's like, you know, it's virtually the same slide. Hey, anything you're doing, you are jointly contributing to both organizations, so be careful what you say. And once we get under that, we get going. And we have a bunch of different models to work with alliance partners. Some people, they want to work with us NDA only before anything goes out the door. Other people, you know, throw it over the wall. We'll do a work in progress externally. They'll submit things to the feedback portal, vice versa. We're really open to working any way anybody sees fit, and have a bunch of different models to work with. DMTF does more than Redfish, okay? There's, you know, we're certainly known for Redfish. I still remember, so Redfish's anniversary was August 4th. It was 10 years. Hard to believe. We started just with servers. And actually, we started with more than servers before the pre-Redfish went in there, and then we beat it back into meet comp with IPMI, and then we expanded it back out to kind of what we had originally, which was local storage, and that was when the relationship with SNIA started, which very much right in that first year. But DMTF does more than just Redfish. First of all, there's SM BIOS. I think it's in every x86 system built in the last 20 years, so there are billions of implementations out there. PMCI, it's inside of every server, whether you know it or not. And anything that is built out of a server has PMCI in there. You wouldn't get very far if you didn't fire up things in the right sequence. And so those management buses are in there to do a lot of other stuff, power and thermal. And, you know, Redfish has to get its information from somewhere. And so, you know, a lot of that dovetails tightly with PMCI. Firmware update, all kinds of stuff, file transfer, diagnostic data, all that. It's all in there. And there's a really good positioning paper on how does all this stuff really work together. You can go to the DMTF's website and see that. Of course, SPDM is near and dear to my heart. I've been working on that for about 5 years now. Just did a session earlier today on SPDM. And it's one of those where, you know, it demonstrated how agile that DMTF was, because the idea came in, and while everyone was figuring out who should do this, it's like, well, we could start up and be doing it next week. So we already had a group that was chartered to do it. We started a task force, and, you know, within a couple of weeks, we were having our first face-to-face. So pretty happy about extending the charter there to security management. And, you know, Redfish is one of those things where I never would have thought it would have gotten as far as it did. We really were just trying to modernize IPMI and make something human readable and machine parsable. And of course, then somebody says, well, I make that out of a server. You do all the power and cooling and infrastructure, and SNIA is probably a pretty good example of that. We don't want to do all the power and cooling and accounts and events and event service itself and all of that. Just let us extend our own little sandbox. So it speaks strongly to the original architecture of Redfish. And it's kind of, not many people realize Redfish was actually born out of SIM. So, and that was interesting discussions if you're an insider in both standards organizations. When Sim was here and we started Redfish, Sim, you know, how can you do that? Well, maybe we could just restify Sim, and I don't think we want 8 different kinds of gets and 13 different kinds of puts. So it was interesting just watching how SMIS evolved into Swordfish as well. So, but Sim is still there, it's still alive. Dash is still around. There's a whole Dash conformance test suite and a registry. There's an ungodly number of implementations out there that are registered for it. So storage in Redfish is really pretty basic, and there's a couple of lines here that I want to point out. Rochelle was pointing out earlier, there's a logical view, and then there's the physical view. Anything off a chassis is pretty much a physical view. Anything off of server is pretty much a logical view, with some exceptions. When we first did the original array controller, we did a storage object, and inside of it was a controller object, not a controller resource. And then we hung drives off of that original storage controller, storage object, and then we hung the volumes off of that too. And what we were trying to do is prevent you from needing to do a chassis just for your storage drives. And what we learned is that just really confused people. So we've kind of switched to the model where drives are hanging off of chassis. That's really the right place to do it. They're a physical thing. The volume is the logical construct. And we also broke out controller. Largely that was part of the NVMe discussion, was controller was just this object, and it's like, well, actually in NVMe a controller isn't just a physical thing, and so you need to kind of break it out and have it available on multiple storage objects, and that kind of helped software define storage and some other things. So there have been some changes to this diagram, so that's why you'll see 2 sets of lines, one dropping off of storage and one going off of chassis that both point to drives. You're only allowed to have it in one location. The URI can reference the other one and use the same URI, but that resource, and that's true for everything in Redfish, is there's only one resource per thing out there, and everything else is just a pointer. So you'll hear us talk about subordinate objects, and that's kind of what we mean there. Go to the next slide. So local storage is, I need my glasses for this one, man. Hang on a second. It's a real eye chart. So it seems like there's every single Redfish release we're adding something for storage. Lately in the last year there hasn't been a whole lot. We're pretty mature. There were a whole lot of changes brought in for NVMe, and you can see a lot of 2024.2 that made it into Swordfish. Lately it's just been drives added. Oh yeah, the hardware version. Man, there was a real debate, and apparently SCSI kind of was very different than anybody else. We've got version and firmware version and revision, and people were using revision for the SCSI revision, and so we needed a hardware version in there in the object just to clarify things completely. So we added that in the 2024.4. Storage controller, we added max attached namespaces. Oh yeah, there's, like if you look in the NVMe controller properties object, so 2 fundamental architectural tenets in Redfish: polymorphism by union and inheritance by copy. And I see a lot of people looking like, what? So what we discovered early on was DevOps doesn't read manuals. And so if you do inheritance, they're not going to go look at the previous object or the previous object or the previous object. They want to see it all in the one object. So we have resource, and everything inherits off a resource. So like for a drive type, there's literally a drive type property in there that says, you know, what's your drive type? Oh, I'm an NVMe drive. And that tells the code to go look for the, in this case, it's NVMe controller properties property to tell you all of the properties about the NVMe controller. And then you can also look at the actual assigned ones. And we had, you know, which were the assigned namespaces, and we didn't have max namespaces in there. So, you know, there's always something you miss, well-intentioned as the first revisions may be. There was a bunch of stuff added in 2024.2 around configuration lock. So the ability to, you know, lock an OS out of configuration changes to the NVMe controller. I'm sure you're all more familiar with that than me. But that was a lot harder exercise when we went through it a year ago than I would have ever thought possible. You'd have thought it had been pretty easy. It turns out there's a lot of wiggle room in the NVMe spec. And some of these favorite properties I have are, which one is it? Baseline, target configuration lock level is baseline. What does that mean? Well, it means there is no one single method of doing it. Everybody has a different method, and their baseline one is the one you're going to get with it. It's not the only place in redfish by any stretch where there's a lot of wiggle room, but that's been one of my favorite ones recently. Configuration lock state was added to both drive and storage because apparently you can do it in both places. Set controller password action was added. So a lot of changes that were put in for NVMe specifically. Those are all the ones that are the recent ones since the last time I presented. If you want to go back and look at the presentation from last year, I covered the ones from the year before. So I kind of want to get into some stuff that's changing that may or may not be related. And one of those is telemetry. We're trying to modernize the telemetry service. And it isn't just AI that's driving that, although certainly it is. What we're kind of discovering is the original metrics report and metric definition isn't really a user-friendly way of doing any kind of metrics. And the metrics that you get out of a BMC aren't necessarily the ones that were going to match the software ecosystem that has developed over the past decade. You know, when we first did eventing, that was a decade ago, and there really wasn't anything out there in the industry that was up for us to model from. There wasn't a standard eventing format, so we made one up. Well, since then, some of the time series databases particularly have helped drive that telemetry solution. And sure, DMTF, we could invent another telemetry format, but then you'd end up translating it into the telemetry format that's needed for your particular device. So what we decided to do was provide the original telemetry data direct from the device and let you know the format. And so you can also trigger it with a collect telemetry data action. So the way that looks is, and this is another eye chart, you see 3 bullets in there. Orange didn't turn up so well, but that first one is OEM telemetry data type, right, where literally that is, you know, whatever, pick your favorite telemetry format, probably came from the manufacturer. You didn't have a lot of choice about the telemetry data coming out of that thing. So that may not be you, Mr. Server Vendor or BMC vendor, that may be the actual device's format. And then there's the target devices, right, the whole list of URIs of where you're going to get this telemetry from. And then there's the telemetry data is the result that comes back from the operation. You get the actual URI of the stream where you can then go and get that data. And so whatever kind of time series database you're using to suck all this into, we've tried to make that as easy as possible. Sure, for the GPU vendors, but they're not the only ones out there.
Yeah, so if I can just reiterate here, this is so much simpler than the model we had before, where we had to do a ton of customization, because if you have a system that's got 1,000 objects and it's got multiple different kinds of telemetry, that was really complicated to model. So this helps a lot, because you could say, oh, yeah, target devices, here's my 1,000 volumes for this set. And then you can create another set that says, here's my sensor.
Yep.
And it really
Streamlines it all, makes it more efficient, do it in one I/O. If you go look at the old metric data and metric report, you needed 3 objects for one telemetry stream, almost on a per device basis if they were different. It was very unwieldy, hard to use, and it was fixed function. There wasn't a lot of flexibility you could have in it. It had to have been put in by the OEM, whoever was doing the BMC. With the telemetry stream, particularly if it's device dependent, and you know what that is, it's a lot lighter weight mechanism to implement on the BMC side, and it's a lot more client friendly when it comes to gather the telemetry data. And then on the back end, you've probably got it in a native format that helps you suck it into whatever reporting mechanism you're trying to integrate with. So we've tried to speed that up a little. And then collecting the telemetry data itself. Here's what it would come back looking like. And you can see the response where it's got the, I guess you can't see that. The timestamp when it came in, the telemetry data type, again, that's going to be OEM. And then there's the OEM telemetry type, and you can see the URI of the full data stream for your request. moving right along, we've spent a lot of time on CXL lately. A CXL switch can contain virtual switches and virtual PCI to PCI bridges, and that's used by fabric managers to control the switch configuration, downstream port binding, and a whole bunch of other stuff. We end up spending a lot more time on CXL than I would have ever thought, but there's two new things in there, and that's virtual CXL switch and virtual PCI to PCI bridge. And so that'll support all the 3.1 features. At this point, except for global FAM, I think we're done with all the CXL changes. The global FAM stuff is still, GFAM is still coming out. We've got a couple of mock-ups coming out as well, showing CXL to CXL multi-switch. So we're going to try and come up with CXL individual switch mock-ups, CXL to CXL mock-ups, and what I'd like to see the industry do, particularly OCP or someone, is come up with those profiles for type 1, type 2, type 3 device, what it looks on the device side, on the enclosure side. Also, what does it look on the system side once it's mapped into local memory, because those are not the same views. Because CXL kind of does some funny things where you can create a memory block, a memory chunk out of DIMMs over here, but to the system, that memory chunk looks like a DIMM. And then you can form memory chunks over it on the system side. That's not intuitive, and yet it's something that, you know, particularly the folks in OFA, once you start modeling that, it's real important to have both profiles and mock-ups to go from.
So if you're wondering about the storage overlap here, we actually do have some persistent CXL devices coming out and hitting the market here shortly. I think there's one out, and there's going to be a couple more. There's a couple more that folks are really looking at. So that's where you'll see the overlap of the CXL models.
Yeah. Out of fairness, it's very memory focused. CXL memory's been getting all the focus, right? And yet, you look at the CXL devices, there's no reason that you can't have a storage device or a GPU or anything else using CXL. I'm not saying you would, but, you know, the market's been slow to see those products materialize.
Yeah, it's really, this is really going to end up being the focus for anyone that's doing like that, persistent memory or Optane style replacements for the functionality. They're moving to the CXL standard, but still implementing a lot of the persistent capabilities.
And there's,
so this is included largely in this model.
Well, without diverging too much into CXL, CXL makes a really attractive, there's a lot of attractive models out there for something, you know, either memory or an accelerator sitting in front of a back-end solution. And prototyping, it's fun to play with, but product-wise, it's equally compelling. So, other changes affecting storage. Conditions type was added to conditions, and conditions was one of those things I thought might have been a dumb idea when we started. So in status, there's this thing called conditions, like, well, okay, we had health and health roll up, which is, gee, the thing I'm dependent upon is no longer healthy, so I might be degraded a little bit. So my health is fine, but what I'm depending on is bad. You know, that really doesn't help a DevOps kind of person figure out what's going wrong. And so we created this conditions array where you can have some of the events even that may be sticky. It's you know, I sent an event. Oh, I can also put the message from that event in the conditions object. And so you can know what's going on in there. And so condition type was added to condition to help strengthen that. I've seen several proposals recently to add even more information into conditions. So, you know, the users are coming in saying, man, this is a really good object, so, you know, it's something I can pay attention to, so help me out. Put some more sticky information in there. So expect to see some stuff coming out this year with more things added to condition. Of course, the message registry for storage device, 1.5 volume rebuilding and volume reconfiguring were in there. As Rochelle indicated, what we had all along in mind was specific message registries, but you could only do so much at first. So we created the generic one, and the immediate feedback from the client guys were, we absolutely hate this, you know. And it basically was the old SIM model, right? thing created, thing deleted, thing state has changed, all those kind of generic objects, and then you had to go look at the thing. Was it a drive? Was it a volume? Was it a switch? What was this thing? Was it a power supply that interrupted me? And having a generic catch-all message and event for that wasn't a solution that was better than what everyone was doing before that, which was OEM-specific registries. We'd have 150 messages from HPE. Dell would have 150 different ones. So I think it'll be a while before we get people to finally move off onto the storage and storage device. But the more we can get conformance programs in place, the better off we can do. Which is something that isn't on these slides, is the Redfish Charter has been published, and there's a little thing in there that allows Redfish to now do conformance. And so we're sticking our toe in the water. It's only been a decade. Why would we start now? We're really, a lot of our companies were reticent for conformance programs that either become a logo program or cost a lot of money. We didn't want a barrier in between shipping and revenue, I guess. So, so Redfish was real reticent to do that. We built the whole tool chain. There's a fantastic tool chain out there, all kinds of stuff being added all the time, clients and toolkits and the rest. But hopefully we'll see some movement in the standard registries, particularly if we start doing conformance programs around it. In summary, that's really all the changes the past year over storage. Redfish, along with our other partners like SNIA, we're really trying to make interoperable standards. It's not just Redfish, although Redfish certainly gets a lot of attention. How many of you are going to OCP? Come by the Redfish booth before Tuesday at 3. Say you saw this presentation. And I'm just going to leave it at that. So hopefully see you there at OCP. We've got the DMTF management workshop that's Monday afternoon. OCP starts Monday this year at noon. So there's 3 workshops that are going on, and then the keynotes start at 4. So the keynotes go for a couple hours, and then there's all kinds of stuff going on, and then they start again Tuesday morning with more keynotes, and then the work stream. So the manageability workshop is Monday afternoon. The hardware management track, storage, and security are all Thursday, and they run all day. So I think OCP stops at about 4 o'clock. So if you haven't, keep your schedule open, man. It's going to be a long week for everybody. But come by the DMTF booth. And they'll be right next to each other, yes. Any questions? All right, thank you very much. Oh yeah, I didn't show you the developer hub. She said dmtf.org/standard/redfish. Redfish.dmtf.org is a lot more developer friendly. So, thanks.